All right, so we're going to continue on with section 9.5, and these are going to be, I'm going to go back over a little bit, just solving regular equations without factoring yet, but that have multiple answers. So the first one is just a little bit of a review from the last conference. Cosine of 4x is equal to 1. All right, and so on this one we want to know where is the cosine of x equal to 1. And so again, we'll look at our ones that land on the axes. So this is over 1 up 0, over 0 up 1, over negative 1 up 0, and then this one is over 0 down 1. All right, so remember the cosine of theta is equal to the x-coordinate, and the y is equal to the sine of theta. So where is the x-coordinate is what I'm looking for. Where is the x-coordinate equal to 1? So that would be at 0 degrees. So this would be 4x is equal to 0 plus 2k pi. All right? And so now, dividing everything by 4, I get x is equal to 0 plus pi over 2. If I cancel the 2 and the 4, I get pi times k. So if I want say all of my answers between 0 and 2 pi, or I'm sorry, not theta x here. All right, then that would be, first I'll let k equal 0, and I would have 0. Then I would let k equal 1, and I would have pi over 2. And then I would let k equal 2, so I'd have 2 pi over 2, which would just be pi. And then I would let k equal 3, and I would have 3 pi over 2. So those would be my 4 answers, because remember, normally we get 2 answers out of each one, but in this case, because I'm on the axis, and I've only got one place where the cosine of theta is equal to 1, then I only get one group of answers, and so these are the 4 answers that come from this one answer of 0. All right, so that's an example where you're only going to get 4 answers instead of usually if I have 4x, normally I get 8 answers. All right, problem number 2 says sine of 3x is equal to, oh, by the way, you also alternatively, instead of drawing your axes, you can just take the inverse cosine of both sides on this one, and you can just do what is inverse cosine of 1, so I hit 1, and then second function inverse cosine, and again I get 0 as my answer, so you can do it that way as well. All right, so now moving on to the next problem. If I have sine of 3x is equal to negative 0.2, all right? And here they just want the 2 smallest answers. But I'm going to go ahead and show you how to do all of the answers, but we're only going to get 2 of the answers as to put in for the homework. All right, so this is saying, notice that the sine of theta here is negative. And so I'm going to look at my 2 reference angles. So I want the sine of theta to be negative 0.2. All right, so all students take calculus. So the sine is positive in the first and second quadrant. And so it's negative in the third and fourth quadrant. Now this is not one of the triangles that I know, and it's not on the axis, so I'm going to have to use the inverse cosine. So theta reference here is going to be equal to the inverse sine, and I'm just looking for my reference triangle here, so I'm just going to do my inverse sine of 0.2. I forget the negative when I'm doing this. And so I'll make sure that my calculator is in radians, and I am going to go 0.2 and inverse sine. And so I get 0.201. All right. And so my first angle in the third quadrant would be, here's pi, and here's 2 pi. So to get this angle in standard position, it would be pi plus 0.201, and that would give me, and where's pi again? Here it is. 3.34. All right. And so then my other one is going to be, notice to go here, I go all the way to 2 pi and then back. So this would be 2 pi minus 0.201. So I'll have 2 times pi minus 0.201. And that will give me 6.08. All right. So here, now I know that 3x is either equal to this or it's equal to this. And remember, it's plus 2k pi. So it's going to be 3.34 plus 2k pi. And I'm going to divide everything by 3. So x would be equal to, first of all, let's do the first one. 3.34 divided by 3 gives me 1.11 plus 2 times 0 times pi over 3, so that would just be 1.11, because times 0, this is 0. All right, then I'm going to let k equal 1, so it would be 1.11 plus 2 times 1 times pi over 3. All right, and so that would give me 1.11 plus 2 times pi divided by 3 equals 3.20, and x is equal to 1.11 plus 2 times 2 pi over 3. So that would be 4 pi over 3. So again, I'm going to take 1.11 plus 4 times pi divided by 3 equals 5.30 if I round it off. Okay, and let's go through that rounding. So if I'm rounding it to 2 decimal places, the 8 wants to make this 9 into a 10. So what I'm doing is I'm thinking 29, and I want to round it up, so that would be 30. All right? And so that gives me all of the ones for 3.34. Now let's look at the ones for 6.08. All right, so I have 3x is equal to 6.08 plus 2k pi. Divide both sides by 3. And I get x is equal to 6.08 divided by 3 equals 2.03. If I round it off, and this will be, the first one will be 0. 2 times 0 pi over 3 would be 2.03. Then I'm going to let k equal 1. So 2.03 plus 2 times 1 times pi over 3. And so that would be 2 pi over 3. So I'll take 2.03 plus 2 times pi divided by 3 equals 4.12. And then finally, I'll let k equal 2. And so that'll be 2 times 2 pi over 3, so that's 4 pi over 3. Or you can do 2 times 2 times pi. So this would be 2.03 plus 4 times pi divided by 3 equals 6.22 if I round it off. So 6.22. And so now my two smallest answers, of course, are going to be the two first answers that I got. So it would be this one and this one. So on the homework, you wouldn't have to go through this whole process. You know that it's just going to be, these are the two smallest answers, and then these will be the ones that come later. All right, and we know that we're going to get 3 answers because this is 3 answers for each of our triangles because this is 3x. Just like here, I know it's going to get 4 answers because I had one, it's not a triangle, but I had one answer, and then it's multiplied by 4. So that would be 4 answers. All right? All right. Problem number 3 says cosine of 3x minus 1 is equal to 0.2397. All right, so here I'm going to take, first I want to draw my triangles. All right, so this would be the cosine is positive. So where is the cosine positive? Well, all students take calculus. So this one, all of them are positive in the first quadrant, and just the cosine is positive in the fourth quadrant. So my two triangles are going to be in my first and my fourth quadrant. So then I'm going to use inverse cosine. So my theta reference will be inverse cosine of 0.2397. So 0.2397, and then inverse cosine, and again make sure you're in radians. So theta r will be 1.33 radians. All right, so this would be 1.33 and 1.33. So my first one's in the first quadrant, so it's just going to be, my first answer would just be 1.33. I don't have to add or subtract pi or 2 pi or any of those things. Then my second one, here's 2 pi, and so I'm going to go all the way around and then back 1.33. So that would be 2 pi minus 1.33. All right, and so 2 pi minus, 2 times pi minus 1.33 equals 4.95. All right. So then I'm going to have 3x minus 1 equals 1.33. All right. And so that's going to give me plus 2k pi. So first I'm going to add the 1 to both sides. And so I'll get 3x is equal to 2.33 plus 2k pi. And then I'll have 3x minus 1 equals 4.95. Then divide by 3. So I'd have x is equal to, and on this one we're going to say they want all of the solutions. And so this would be 2.33 divided by 3 equals 0.78 if I round it off. Well, let's go 0.77 if I round it off to 3 decimal places, plus 2k pi over 3. Now, k here can be any positive or negative, so it's an integer, so positive or negative, but k is always an integer, but you can subtract 2 pi, because remember, this is coterminal if I keep going, or what if I go backwards? Remember, I can add or subtract pi, 2 pi as many times as I want, and I'm going to get the same coterminal angle. And so k here is any integer. So I don't need to say plus or minus because it's any integer, all right? And so it can be positive or negative. And then this one, 2 plus 2k pi, add 1, and I get 3x is equal to 5.95 plus 2k pi, and then divide both sides by 3. So if they ask for any, all solutions, you leave the 2k pi in there. So this would be 5.95 divided by 3 is equal to 1.98. Three, if I go to 3 decimal places, plus 2k pi over 3, all right? And so that's how you do the problems where they say, give me all the solutions. You're going to have that 2k pi in there. And if they say, what numbers can k represent? Well, k represents all integers, both positive and negative, and including 0, all right? All right. Problem number 4. Says 25 sine of t cosine of t is equal to 5 times the sine of t. Now this is the first one that we see that we're going to have to do factoring on. So this one is going to be, first I set it equal to 0 so I can factor it. Notice I cannot divide both sides by 5 sine of t because then I'm losing some of my answers. So you can't divide by anything that might equal 0. All right, so you have to subtract the 5 sine of t here. So just bring it over to the other side, changes sides, changes signs. Now I am going to factor out 5 sine of t. And if I do that, I get 5 cosine of t minus 1 equals 0. So 5 into 25 goes 5. Then the sine and the sine cancel, and I just have cosine of t. And then 5 into 5 goes 1 time, and sine of t into sine of t goes 1 time. And so that's how this factors. So now I'm going to set each factor equal to 0. So this is just like when we were in algebra. So you set each factor equal to 0. So 5 sine of t equals 0, and 5 cosine of t minus 1 equals 0. All right? Now on this one, divide both sides by 5, and I get the sine of t equals 0. So now let's see, where is the sine of t equal to 0? So again, looking at my 4 points on my axis, this would be over 1 up 0, over 0 up 1, over negative 1 up 0, over 0 down 1. So remember, the sine is the y-coordinate. So where's my y-coordinate? 0. It would be here at 0 and here at pi. So I get 2 answers, 0 and pi, for this one. All right? Now on this one, I'm going to say I have to solve for cosine of t. So first I'm going to add 1 to both sides, so I get 5 times the cosine of t equals 1, and then divide by 5, and I get the cosine of t is equal to 1/5. All right? So again, we need to look and see where is my cosine positive. So it would be, all students take calculus, so it would be in the first and fourth quadrant. And so now I'm going to take the inverse sine of both sides. And so I'll do, inverse cosine. So theta reference is equal to inverse cosine of 1/5. And so I do 1 divided by 5 equals, and then inverse cosine, and I get theta reference is equal to 1.369 if I round it off to 3 decimal places. And so this one in the first quadrant will just be 1.369 because it's in the first quadrant, and then this one would be 2 pi all the way around and then back. So 2 pi minus 1.369. So 2 times pi minus 1.369 equals 4.914. And notice on this case I didn't have to do plus 2k pi because the t's are not multiplied by anything. So when you get your answers, those are your answers. So we'll do some more problems on the next video.